Alright, welcome to the last part of our video series for 6-4 Box and Whisker plots. If you haven't already done so, please make sure that you check out the first two videos in this series. In our last lesson, when we were looking at histograms and looking at dot plots, we were able to describe those visual displays by their shape. We're going to be able to do the same thing with the Box and Whisker plots. We're going to mainly be looking at skewness when we're talking about Box and Whisker plots. In a box plot that is skewed left, the left side of the box will be larger than the right side, and the left whisker will be longer than the right one. If you see in our example here, our left whisker and our left box are both bigger than your right box and right whisker. Because those tails are longer, they're going to pull our mean closer to that direction. So in this case, our mean will be less than our median, because that data is going to pull the mean away from that center point. If we're looking at a box plot that is symmetric, we're going to have approximately equal length boxes and equally length whiskers. And it might not be perfect, but they're going to be roughly the same. And when we're looking at symmetric, since it has about even data on either side, we're going to say that our mean is approximately equal to our median. In the box plot that is skewed right, the right side of the box will be larger than the left side. Also, the right whisker will be longer than the left one. And I'm going to try and drag my camera here so you can see down there. That way I'm not blocking your view there. But in this case, since the data is being pulled to the right, our mean will be greater than the median. Alright, the last thing that we're going to discuss, and before I flip to that next slide, I'm going to drag the camera back down to the bottom. We can talk about where the data is going to lie within this. Now, one of the nice things about a box and whisker plot is that it divides our data into really 4 sections. And within each of those 4 sections, we're going to have 1/4 or 25% of the data. So we're going to see that 25% of the data lies between the minimum and the first quartile. We're also going to have 25% of the data between quartile 1 and quartile 2. We're going to have 25% of the data between quartile 2 and quartile 3. And as you probably guess, 25% of the data between Q3 and our maximum. A couple other conclusions that we can draw from these facts above. If we're looking at how much data lies below the median, so from here to here, that is 2 sections of 25%. So if we add those together, we're going to have 50% of the data below the median. Similarly, if we go from the middle to the top, we're going to have 50% of the data above the median. Now, if you notice, this is a good point to make. Even though this section looks larger than the second section, they're both going to have the same amount of data in between them. They're both going to have that 50%. What that tells us, since this 50% is smaller than this 50% as far as shape on the actual box and whisker plot, that this 50% of the data is going to be closer together than this 50% of the data. Still going to have equal amounts of data within them, but you can tell how spread apart they are based on how long their box and whisker plot sections are. And the last conclusion that we're going to make is that 50% of the data lies between quartile 1 and quartile 3. So in this box area, again, you have 2 sections of 25%. That's going to give you another 50%. And you can really combine these in any method. You might be asked sometimes what percentage is greater than Q1 or less than Q3. We can use the fact that each of these sections is 25% to help us figure that out. Alright, there is not an application for 6-4. Make sure that you complete the practice. This concludes our 3-part video series for 6-4. Get that practice done and begin preparing for your mastery check. See you guys in our next lesson.